Hello, students. Today we are going to be working through a new topic, a problem solving topic that scientists use. So, for today's lesson, brainstorm some possible reason a car will not start and be ready to share them. So, here we go. So, oh no, your mom's car won't start. You're going to be late for school. What are some possible reasons why the car won't start? I'm sure all of us probably have some experience with this. So we could make a long list of reasons. Might be ran out of gas. Might be the battery's dead. Might be something more internal. It's out of oil. Oil leaked out. Overheated. We could come up with a long list of reasons why the car doesn't start. But regardless of the reason, we still have a problem. And so today we're going to go and use this example that most of us are kind of familiar with to go and illustrate how scientists would solve a problem. So first thing we need to do is state our problem or question that we have. And sometimes it's just a question that scientists have. They're trying to figure out the answer to it. But today we're going to go and start with a problem. So our problem is, well, the car will not start. That is our problem. And so we're going to go and do some observation, maybe a little research. Maybe we're going to go online and look a little bit about our year of car, why it won't start. Sometimes it's like the security alarm that goes off or it has a malfunction and that's why it doesn't start. Maybe we want to do some research online. But we're going to start with just observations. Remember, observations are facts that everyone would agree with. So we look around the vehicle. We don't see any puddles underneath there, so no fluids are on the ground. We look inside of the vehicle to see if we can notice anything. And our gas gauge shows empty. We also go and notice that when we get inside the vehicle, that the lights inside do not come on when the door is open. So those are all observations, things that every single person that comes to the scene would agree with. They all see this. And the next step is we're going to form a hypothesis. And a hypothesis is just a reasonable idea or a guess that we can go and use to explain what might be happening based upon our observations or our research. So it's an educated guess. And we are going to form a hypothesis. What do we think's wrong with this situation? Why is the car not starting? And so we are going to go and make sure it is something that we can test. We're going to use an experiment to test it. So well, let's just pick one. Our gas gauge showed that it was empty, so let's just put some gas in. So if I add gas to the car, put gas in the car, then the car will start. So that's our hypothesis, our educated guess. Can we test it? Sure. What do? We put gas into the car. Notice we're doing one thing at a time. We're not doing 20 things and then trying to figure out what was wrong with the car, because if we do them all at the same time and then test it, we'll never know which one was the problem. So we're going to do one thing at a time. So we're going to form our hypothesis, and then we are going to test one thing. So we're going to put some gas in the car. So you go get the gas tank that's in the garage for the lawnmower, put some gas in the car, and then we're going to test it. And how could we test this hypothesis? Well, we put it in there, and then we try starting it. So we do that. Put the key in the ignition, and time to test, and turn the key, and nothing happens. And so therefore, we are at our next step. We are going to draw a conclusion. The car did not start. That's interpreting our data. Was our hypothesis correct? No. We still have the problem. We did not get the car to start by our hypothesis, which was putting gas in the car would make it start. So we need to revise our hypothesis and experiment again. So we're going to choose a different reason. Let's go back to what we had before. We opened the door and we didn't see any lights. That was our observation. So let's say the battery is dead. So if I jump start the battery, and we have these handy jumper cables that you just put on there that have a battery hooked up right to them. And so if I jump start the car, then the car will start. That is our new hypothesis. We are going to be able to test it. We're going to do an experiment again. So once again, we get inside the car with them hooked up, and we turn the key, and voila, the engine starts. We will make it to school in time. We're going to analyze our data and draw our conclusion. This time the car did start, so therefore we know the problem was we had a dead battery. And scientists do steps like this all the time. We call it the scientific method. And so I would like you to take out your notes and have you copy down these 6 steps in the scientific method. So here we go. The first one, you're going to state the problem or the question. So we had a problem. It was the car won't start. Sometimes it's a question. Why does this kind of cancer form in these younger people or older people? It's a question and they need to go and find an answer for it. The next step, we're going to do some research. Has anyone had this problem before? Has anyone looked into this question? We're going to make observations. We're going to come up with different possible reasons that it could be happening. We're going to brainstorm. We're going to form a hypothesis, which remember is an educated prediction about what will happen. We don't know if it's true or not. It is a prediction and could be wrong. It could be accurate. We don't know yet. The next step is we're going to do an experiment. We're going to test that hypothesis. We're going to find a way to figure out if we are correct with our hypothesis or not. And during the experiment, we're going to make all sorts of observations, not inferences, observations, facts that all scientists would agree with. Then we're going to analyze those observations. What do we see happening? And the final thing is to state a conclusion. This is where we actually do our inference. Sixth graders are really good at doing an experiment, but when they start looking at everything, they want to jump right down here to conclusions and making inferences. But we have to make observations during our experiment to see if it was accurate or not. So those are the steps to the scientific method. Now, sometimes they might not go in this order. Sometimes we might go and have a question and we have to go and look at other people's data that they've collected about that problem, and it could go in a lot of different ways, but this is the general order that you would see in the scientific method, and we'll look at some examples of that today. So first, you identify your problem, you come up with some possible solutions, you have to gather some information, pick one of the solutions, and then try it out. Okay, you're going to form a hypothesis. You try it. You do an experiment. Analyze if it worked. If it didn't work the first time, you revise your hypothesis. And then you go through the whole process again until you finally come to a conclusion. So that is the scientific method. And we are going to be using that. You are going to be designing this. I said you are going to be designing an experiment later this week in which you need to use the scientific method to figure out a problem or a question that we have. And we are going to go through each of these steps and see what we come up to for a conclusion.